For normal in-flight operations, all required electrical power is provided by two engine-driven generators. A third generator, driven by the APU, is available in flight. It is equal in size and capacity to either engine-driven generator. Any two of these three generators meet all electrical requirements. With only one generator available, an electrical load management system automatically shuts down some low-priority items, such as the galleys. Let's use the electrical synoptic to show the main electrical components. Two main AC power buses, left and right, distribute power to all airplane electrical systems. A bus tie and two isolation relays operate automatically to ensure both main buses remain powered at all times. Now let's operate the system. Let's begin with the airplane secured and external power disconnected. Controls for the electrical system are located on the overhead panel. With all electrical power switched off, the main battery still continues to power a few important items through the hot battery bus. These include engine fire extinguisher bottles, the APU fire extinguisher bottle, and the ADARU, as long as the ADARU switch is on. Turn on the battery. The on indication in the battery switch appears, and several flight deck annunciator lights illuminate. Now let's connect ground power to the airplane. There are two external power switches on the electrical panel, primary and secondary. The available light indicates primary external power is connected to the airplane and is of usable quality. Push the primary external power switch to connect external power to the main airplane electrical system. The on light indicates primary external power is connected to the airplane's main electrical system. If no other power source is available, the primary external source powers the left and right buses. With a single external power source, some non-essential electrical items, such as the galleys, may be unpowered if loads are high. Connecting secondary external power to the airplane gives full electrical load capacity for most ground situations. When secondary external power is available and of usable quality, the available light illuminates. Connect secondary external power. Notice the on light illuminates and the available light extinguishes when secondary external power is connected. When both primary and secondary external power are available, primary powers the right main bus, and secondary powers the left main bus. Any two power sources support full electrical loading. In this example, the APU is running but not connected. Let's connect the APU generator to the system. Push the APU generator switch to the on position. Notice that APU power replaces secondary external power. The external power switch changes to available. When the APU is running and primary external power is online, the APU powers the left main bus, and the primary external power source powers the right main bus. The APU generator switch is normally left in the on position at all times. In the on position, the APU generator breaker opens and closes automatically. There is no interruption of power when switching power sources, except when switching between two external sources. Remove primary external power. Notice the primary external power switch changes to available. The APU now powers both buses. With only one power source, the electrical load management system again sheds non-essential electrical loads. Re-establish primary external power. Re-establish secondary external power. The only indication of the change from APU power to external power is the available annunciation changing to an on annunciation in the external power switches. Each main engine generator and its drive unit are housed in a single case and share a common oil supply. This combined unit is called an integrated drive generator, or IDG. Each IDG is controlled by a generator control unit, which provides automatic control functions and system protection. The generator control switches automatically connect the IDG to the main buses. The generator control switches remain in the on position for all normal operations. In this position, the on is in view and the breakers are armed for automatic operation. The off light illuminates when the breaker is open. Note this is different than the APU switch, which only illuminates with a fault or when the switch is turned off. Now let's start the right engine. The IDG begins to rotate to operating speed. The generator breaker closes, and the right generator off and drive lights extinguish. The right generator now powers the right main bus. At the same time, primary and secondary external power automatically disconnect from the main buses, and the right generator also powers the left main bus. After a few seconds with the APU running, APU power replaces right generator power on the left main bus. When the left engine is started, the left bus tiebreaker opens and the left main bus is powered by its own generator. Each main AC bus powers one utility bus. There are no switches for the utility buses. For normal operation, the bus tie switches are left in auto. In auto, the bus tie breakers keep both main buses powered at all times from any available source in a priority order. The first priority is the associated engine generator when available. Second is the APU generator. And third is the opposite engine generator. External power is the only AC power source not automatically selected. You must apply it manually. Note that both bus tiebreakers are open whenever the IDGs are powering their respective buses. Push the left bus tie switch to position it off. Notice the auto annunciation disappears and the isolation light illuminates. The left bus tiebreaker is locked open with the switch off. Faults associated with the isolation lights are covered in another lesson. However, notice that even though the right bus tiebreaker is open, the right bus tie isolation light remains extinguished. The isolation lights always remain extinguished when the bus tie switches are in auto and the bus tie breakers are performing their normal automatic operation. Reset the left bus tie switch and notice that auto is again annunciated. Both engines are now running and both engine generators are powering their associated bus. The only indication on the electrical panel is that the generator off lights and generator drive lights are extinguished. The electrical panel is now configured for flight. External power is disconnected. Notice in this normal flight configuration, all electrical panel lights are extinguished. The APU may be shut down. The system uses two power sources to keep the buses powered unless only one power source is available. Any one generator has sufficient capacity to supply all essential flight loads. If only one power source is available, the electrical load management system load sheds non-essential loads. First, galleys and galley chiller loads are shed, and then left and right utility buses. The utility buses power passenger entertainment systems and recirculating fans. Now look at the automatic switching that takes place during the normal shutdown procedure. You have arrived at the ramp. The APU is running and primary external power is available. Let's shut down the left engine. When the fuel control is moved to cutoff, the IDG synchronizes with the bus tie. The left bus tie breaker closes, the engine generator breaker opens, and the APU powers the left bus. The right bus is still powered by the right engine generator. When the right engine is shut down, the right bus tie breaker closes, and the APU automatically powers the right main bus. To keep the main buses powered, select external power prior to APU shutdown. Notice that primary external power now powers the right main bus, and the APU continues to power the left main bus. Now turn the APU off. If the APU is not available, select primary external power prior to engine shutdown. Select primary external power. This causes both generator breakers to open, and primary external power now powers both main buses. Since this is not a through flight, the airplane is secured and external power is disconnected. The main buses are now off. The only remaining source of power is the main battery. In addition to the previously mentioned systems, the battery powers the standby power system, the captain's displays and CDU, and the left airplane information management system, AIMS. Now complete the power down. Turn off the battery. All electrical power is now off except those items continuously powered by the hot battery bus. The airplane has been parked overnight. You are preparing for the first flight of the day. Establish full electrical power. The airplane just landed and is taxiing to the gate. Prepare for engine shutdown. The engines are shut down and external power is plugged in. Establish external power. Set the electrical panel to secure the airplane, but keep external power connected for maintenance personnel. Now turn the APU off. Two buses provide power for servicing the airplane: the ground handling bus and ground service bus. There are no controls for the ground handling bus. The bus is automatically powered when external power is plugged in. The APU can also power the ground handling bus. If external power is not available and the APU is running, the bus is automatically powered. If the APU is running and external power is plugged in, external power has priority. The ground handling bus powers the cargo doors, cargo compartment lights, and maintenance access lights. The bus is not powered in flight. Now let's look at the ground service bus. The ground service bus is for cabin service personnel. The ground service bus powers loads needed both on the ground and in the air. It powers cabin lights and outlets, battery chargers for the main and APU batteries, and the left forward fuel pump, which supplies fuel to the APU. When external power is the only source of power, and the main buses are not powered, a ground service switch at the attendance panel at door 1 left can be used to power the ground service bus. Whenever the right main AC bus is powered, the ground service bus is powered. If the right main AC bus is not powered and the APU is running, the ground service bus is powered by the APU generator through the same ground service switch. DC electrical power is used to operate important items such as the primary flight displays and the navigation displays, Global Positioning System or GPS, and the Air Data Inertial Reference Unit or ADIRU. Now let's look at the sources of DC power. The 777 has 2 batteries. The APU battery powers the APU starter motor and APU control circuits. The main battery powers critical airplane systems when no other power sources are available. Battery functions are monitored by the Electrical Load Management System, or ELMS, and displayed at the bottom of the electrical synoptic. Also, battery messages are displayed on EICAS. The primary source of DC power is 4 transformer rectifier units, or TRUs. The TRUs convert AC power into DC power. They are powered from the 2 transfer buses. The TRUs in turn supply 4 DC buses: the left main DC bus, the right main DC bus, the captain's flight instrument bus, and the first officer's flight instrument bus. If a TRU fails, DC tie relays connect the left and right main DC buses and the captain's and first officer's flight instrument buses. This allows all buses to remain powered. There are no controls for the DC system, as it is fully automatic. The flight controls on this airplane are actuated hydraulically, but controlled electrically. This is known as fly-by-wire. There are 2 backup generators, 1 on each engine. Each backup generator is a non-time limited backup source. We'll discuss the backup generators in more detail in non-normal operations. 2 permanent magnet generators, or PMGs, are housed within each backup generator. These PMGs are the power source for the flight controls. The PMGs provide dedicated power to left, center, and right power supply assemblies and their respective flight control DC buses. If 1 or more PMGs fail in flight, the main DC buses or the captain's flight instrument bus power the flight control DC buses. If the main DC buses become unpowered, the hot battery bus provides power to the left and center power supply assemblies. Should a transfer of power from one source to another occur, 1-minute batteries are provided on each power supply assembly to ensure no interruption of power during the transfer. To allow automatic landings with the lowest possible minimums, the electrical system configures so that each of the 3 autopilots is powered by a separate power source. During approach, power to the right transfer bus switches from the right main AC bus to the backup generators. This transfer provides independent sources to each of the 3 autopilots. The electrical system returns to normal when an autopilot go-around is performed or when the autopilots are disengaged. The 777 has a backup power system consisting of 2 backup generators. These ensure electrical power is available for essential loads. Essential loads are powered by the left and right transfer buses. Essential loads include instrument and panel lighting, captain's and first officer's navigation and communication radios, and center pitot and engine probe heat. The transfer buses are normally powered by the left and right main AC buses. The transfer buses connect to one of the backup generators when their AC buses are unpowered. They are normally left on. The backup generator switch off lights remain illuminated until their associated engine is running. With the engines running and the backup generator switches on, automatic switching is armed. Notice that the backup generators are running. Push the left backup generator switch to the off position. With the switch off, power to the transfer buses is not available from that generator, even though the generator is operating normally. Now reset the switch. The backup power system provides uninterrupted transfer of power to essential loads in the event of loss of one main AC bus, the loss of both main AC buses, when only one main generator is available, and during autoland. In the event of loss of all main and backup generators, a standby system powers critical AC and DC equipment. Critical AC loads include center ILS and radio altimeter, marker beacon left, ATC transponder left, VOR left, and engine igniters. Critical DC loads include the captain's and first officer's flight instruments and displays. The standby system consists of the battery buses, the captain's and first officer's flight instrument buses, and an AC standby bus. Normal power for these buses is from the left and right AC transfer buses, either directly or through TRUs. Should the transfer buses become unpowered, a ram air turbine or RAT provides DC power through the TRUs. And the standby AC bus is powered from the battery bus through a standby inverter. The ram air turbine or RAT can be deployed in flight to provide electrical and hydraulic power simultaneously. It is the primary source of standby electrical power if all normal sources are lost. It is located in the aft right fairing and is a non-time limited source of power. However, its output is small, providing less than 1/10 the power of the other generators. The RAT is deployed automatically if both AC transfer buses are unpowered. If all 3 hydraulic system pressures are low, or with dual engine failure and the center hydraulic system pressure low. If the rat fails to deploy automatically, the crew can deploy it manually. The ram air turbine switch is located on the hydraulic panel. Deploy the rat. The ram air turbine unlocked light illuminates when the rat is not in the fully up and locked position. The pressure light illuminates when the rat is producing normal hydraulic pressure to the flight controls. If the rat is unable to maintain hydraulic pressure, the electrical load is shed until hydraulic pressure is satisfactory. When rat electrical loads are shed, or during periods prior to rat deployment, the main battery powers the standby power system. When the rat provides electrical power, both the captain's and first officer's flight instrument buses are powered. When the battery provides standby power, only the captain's flight instrument bus is powered. Now let's look at some non-normal indications. Shortly after takeoff, the EICAS advisory message "Electric Generator Off Left" displays, and the off light in the generator control switch on the overhead panel illuminates. A generator fault caused the protection circuits to trip the field and the generator breaker to open. Pushing the left generator control switch off and on resets the system. Reset the left generator. The fault was temporary. The EICAS message is removed and the generator operates normally after resetting. During climb, the EICAS advisory message "Electric Generator Drive Left" displays, and the left generator drive light illuminates. The message indicates there is low oil pressure in the generator drive. Hold the guarded switch for 1 second to disconnect the generator drive from the engine. The generator drive is now disconnected. It can only be reconnected by maintenance action. High generator drive temperature automatically disconnects the generator drive, giving these same indications. With the generator drive disconnected, the message "Electric Generator Off Left" also displays, and a backup generator is immediately connected to the left transfer bus. The associated engine generator is lost for the duration of the flight. The right engine generator powers the left main AC bus. Power to the left transfer bus is supplied by the left backup generator. The APU can be started to provide a second generator for the system. Start the APU. The EICAS messages may be canceled. Cancel the messages. After the left engine generator fails, the right engine generator fails. The APU now powers both main buses. With 2 generators lost, the right backup generator powers the transfer buses. Only 1 backup generator at a time can power the transfer buses. Reset the master caution system. During cruise, The caution message, Electric AC Bus Right, displays. This indicates the right main AC bus is unpowered. Items powered by the right main bus are lost. However, the backup system continues to power the transfer buses. The EICAS messages may be canceled. We are cleared to descend. The EICAS advisory message, Electric Backup Generator Left, displays, and the Backup Generator Off light illuminates. This indicates the left backup generator has failed. Notice the right backup generator continues to power both transfer buses. Pushing the backup generator switch off and on allows the circuitry to reset. Reset the backup generator. The condition was temporary, and the left backup generator is now back online. We are cleared for the approach. Autoland is possible with one main generator and one backup generator operating. Several electrical EICAS messages are for crew awareness only. There are no associated orals, and crew action is not required. Information about these messages is available next.